In this video, we will be examining inverse functions. To start, we will compose f of g of x as well as g of f of x. G of x, we know, is x over 3 plus 2/3, and we can use this output value for f of x. So we rewrite this as 3 times x over 3 plus 2/3, all of that minus 2. Distributing this 3, we have x plus 2 minus 2. Our 2's will cancel out, and we'll be left with x. Now when we compose g of f of x, we know that f of x equals 3x minus 2. So we can plug that into g of x, and we get 3x minus 2 all over x plus 2/3. We can rewrite this as 3x over x minus 2 over x. Over 3. This should be over 3. So we will rewrite this as 3x minus 2 over 3 plus 2/3, and we can simplify this to 3x over 3 minus 2/3 plus 2/3. Our 2/3 will cancel out. Our 3's will cancel out, and we will again be left with x. We can see here that when f of x was composed with g of x and g was composed with f of x, we had a result of x for both. In a sense, the functions are undoing one another, and functions that exhibit this behavior are called inverses of one another. We can denote this as f of x equals g inverse of x, and g of x equals f inverse of x. It is important to note that this -1 is not an exponent, and it represents the notation for an inverse function. Therefore, we can state that when two functions are composed and undo one another, then they can be considered inverses. And we write that as we have shown below.